Hi, I'm Matt Lewis, and today I'm going to talk about strategies I've been using in my studio courses that make use of emerging technologies. I'm an assistant professor at The Ohio State University, where my position is split between three areas: our Department of Design, a research center called ACAD that focuses on the use of computer animation and emerging technologies for interdisciplinary research, and finally, TDAI, our Translational Data Analytics Institute. While my education was in computer science and philosophy, I've been working with technologies in interdisciplinary collaborations, primarily in the arts and humanities, for the past few decades. For most of my career, I've created classes that introduce important emerging computer technologies in a discipline-neutral manner to students from areas as diverse as art, design, dance and theater, computer science, and industrial systems engineering and architecture. My primary goal is to expose students to the capabilities of these technologies so they can apply them to problems in their own fields and visualize them as interacting components in complex systems. When providing our students with opportunities to engage with emerging technologies, complexity can be easily identified in many contexts. The first couple I list here are familiar to all of us. Companies employ project managers to track and manage collaborative efforts for very good reasons. I won't be talking about these first two so much as the remaining three. I rarely provide narrow design problems for my students to solve because they always have such diverse interests and goals. Design students in particular are very used to being provided with well-defined situations and almost always a specific set of deliverables. And yet I find that it's very more common that I encounter much more open design situations. Given our resources and capabilities, what's the best thing we could do next? I'll talk more about such problem discovery in a minute after a bit of context about our students and studios. I'm naming these last two complexity sources in this list a bit ambiguously, but what I mean is learning about new technologies versus the technologies we use for learning. These can even feed back into one another as well. Half of my classes are taught in the design department, where all of my students are studying design. In my undergraduate design studio course, students are required to collaborate in groups that are a mixture of different types of design majors and years. While in my graduate design studio, students have just started one of two MFA program tracks. DAME is more explicitly focused on critical making, and most are interested in computer animation, games, and interactive media, while the DRD students are more focused on aspects of design research methodologies, such as human-centered design, co-design, and so on. Our design department just so happens to be housed in the oldest building on campus, shown here, in one of the largest universities in the US. So another source of complexity is navigating and accessing different facilities and resources that our students would like to make use of. In the graduate level design studio I teach, students arrive for their first semester with very diverse backgrounds and disparate professional goals. The grad students shown here that were collaborating on one project team were interested in researching subjects such as mental health, biophilia, voice interfaces, and virtual reality. In this studio, I try to get new students comfortable with approaching and learning about new technologies. They're encouraged to consider and abstractly represent their design processes and to use visualization as a tool for inquiry. I've developed a three-part structure in which students first visualize their research interests, then do some hands-on learning about learning, and finally they end with research prototyping. We learn a bit about topics such as generative design, systems thinking, complexity theory, technology ethics, possibility spaces, and introduce technologies that are useful for prototyping. All of our upper-level undergraduate design students are required to choose between 6 different collaborative studio sections, each having a different annual topic. While my studio is primarily about emerging technologies, other faculty's topics include things like sustainable retail, healthy cities, and social design. These third and fourth year undergraduates span our 3 different design submajors: visual communication design, industrial design, and interior design. In nearly all of their other design courses, they stick with their cohort within the same year and same major. This studio is one of the very few opportunities they have to work with students from other years and other design majors. So I mentioned problem discovery earlier. In both of these design studios, I cultivate a straightforward process that has emerged out of my reductionist engineering tendencies, but crossed with my artistic use of generative systems. Whether the students are in collaborative groups or individually navigating the spaces of their individual interests, they're asked to collect a set of topics of interest, given a few constraints, to consider the complex intersections of these topics, and then to investigate the intersections of these topics through mapping and making. They then discover where this leads them. Note this seems to be somewhat unusual for our design students, who seem to be much more initially comfortable being assigned narrower problems to solve. Choosing a problem is more common in the arts and grad school, and being asked what they're interested in learning about is surprisingly stressful to some, while others immediately embrace such unexpected freedom. Both design studios, undergrad and grad, begin by asking students to identify unfamiliar technologies they're individually interested in learning about. These are typically things like AI, virtual or augmented reality, 3D printing, and so on. Every student is asked to identify additional research topics that interest them. These might be subjects such as sustainability or education, or perhaps personal interests such as coffee or sneaker culture. Graduate students are asked to choose a social issue, while undergrads choose subjects related to an annually changing studio topic, which has ranged from data analytics research to digital humanities to the future of design. Students are given opportunities to use their design skills to visualize connections, projects, and relationships within the web of topics they or their group have selected. Students iteratively produce topic maps, grids, and graphs of varying forms in attempts to organize the complex information spaces that they generate. Using these typically complex 2D information maps, students are asked to further represent this abstract space of concepts using their favorite design tools and methods. Students combine 3D modeling, motion graphics, physical making, animation, and lately generative AI to create representations of the complex overlapping interests that they've assembled. One very unique problem I encounter is showing examples of what I mean when I talk about generating such exploratory visualizations always means some students simply adopt the strategies I've shown. The more I do not share prior examples, the more stressed some become, thinking that there must be some correct answer, but then the more diverse and creative their results tend to be, which they almost always are very happy with. And just a quick credit to the 5 groups of students who did such an amazing job coming up with wonderfully diverse solutions this year, including stories, menu cards, drink recipes, and exercise spaces, and for the first time, baked goods was a new visualization medium. In both design courses, I also asked students to select unfamiliar technologies and then design system prototypes and diagrams, explaining how such systems might work. This provides them with new alternative approaches for considering complex system representations. This is where we focus on the processes by which they learn about new technologies, as well as examine technologies they might use for their learning. Technologies students wish to learn about lately include things like 3D scanning, 3D modeling, Internet of Things infrastructures, and responsive environment components. The typical sort of technologies we look at for learning include social media, search engines, videos, hardware kits, and so forth. But technologies such as augmented reality, AI, and virtual reality also can help us learn about other technologies by allowing for prototyping of speculative systems. For example, students use augmented reality when shooting videos to virtually place objects or even environments that they've designed in a space. They can then make films showing students interacting with the objects or spaces as if they were actually there. Again, I'd like to credit these students for their very creative emergent solutions within their combined spaces of topics and interests. My design studio classes involve managing complexity, but we only briefly explicitly cover it as a specific topic. I do point them to a few short readings that seem to be very accessible. Sarah Firth's Making Sense of Complexity is subtitled A Case for Embracing Ambiguity and Celebrating Uncertainty. Sarah is a comic artist and graphic recorder who's made a wonderful visual explainer for understanding real-world examples of complex systems. Examples of the wolf purge of Yellowstone and the evolution of coffee supply chains are particularly good. Most students have heard so much about design thinking that Vasello's short essay about systems thinking provides a good contrast. And finally, Donello's numbered list with a few concrete points about each item has something that everyone can immediately connect to their own design experiences. Complexity theory and systems thinking arise organically in my other interdisciplinary technology studio courses as well. At ACAD, our Computer Animation Research Center, I teach studio courses such as Introductory Programming for Artists and Designers, Procedural Animation, and Performance and Installation Technologies. The students in these classes have always been a diverse mix from art, theater, and dance, but also architecture, computer science, and systems engineering. It should be noted that a handful of my students straddle these disciplinary boundaries. Double majors in art and computer science is a great combination, for example. Teaching students from both the arts and sciences in these courses has been extremely rewarding for all involved. While those in the arts are learning formal processes for reducing complexity, for example through coding, engineers who are already programmers simultaneously get a chance to explore making in more ambiguous problem spaces than they might normally be used to. When I'm asked how this works out, I like to give the example of grad students who are on the verge of becoming painting professors, relearning about sine and cosine so they can use code to generate color and shapes, while PhD students in engineering are learning basic color and spatial design theory and how to translate that into their familiar mathematical terms. These two groups seeing each other's work in the same class is invaluable. In my courses, I teach shaders, virtual environments, performance installation, responsive environments, as I mentioned. And these courses are structured to introduce techniques and technologies to these students, such as procedural materials, generative virtual spaces and drawing, and responsive environments. I'm showing here the sort of work that I introduce the students to. In groups or as individuals, they're then asked to apply these techniques to their own research and interests. MFA artists integrate algorithms into their paintings and projection, while engineers and set designers might prototype interactive systems. In many of my classes, we gravitate towards working with interfaces that attempt to reduce complexity through visual interfaces for building algorithms based on visualizing the flow of data. Virtual environments, materials, video, sound, interaction, and movement can all be constructed using tools such as Houdini or MaxMSP Jitter. In other classes, students might use Blender, Isadora, or Touch. But regardless of visual or code-based interfaces, when teaching, I practice a bottom-up strategy of building from basic skills instead of starting with complex examples. This has the advantage of resulting in simpler student initial outputs, but the advantage of students acquiring conceptual knowledge that they can apply more generally. I construct assignments as multi-stage, open-ended exercises, structured such that there's easier steps to try first, followed by more difficult challenges. Through these strategies, all students can have a few confident successes, while also gaining a sense of the infinite possibilities that they can choose to investigate next if they wish. I talked first about my role in the design department, then in our animation center, and let me mention briefly that I sometimes have been able to bring students over into my data analytics world as well. The undergrad collaborative design class has studied the data analytics research building and workspaces for collaborative design as a research topic. My graduate design students have also worked with me on research projects taking place in this environment, involving virtually situating data visualized using AR and VR within the Institute. We've particularly focused on visualizing spatially located humanities data. Note that none of this should be interpreted as purely promoting the uncritical adoption of technologies by students. For nearly every hyped emerging technology, there's usually a corresponding techlash. While now we're debating existential risks and potential IP theft implications of AI, recent years have seen pushback against the potential excesses of the metaverse, all things crypto, surveillance capitalism, and so on. While many students are enthusiastic about learning new tools and capabilities, other students express concern about technology itself as a topic of focus. Technology can be obviously viewed as a harmful force in the world. Throughout my courses, I try to constantly reintroduce complexity into most discussions that involve simple binaries. It's not uncommon that I hear, this technology isn't what's important, or this technology is just a tool, or that technology is bad. I try to get my students to notice such binary statements when they appear and seek a balance between enthusiasm and concern. Such discussions invariably turn to power and ethics. We can almost never say something is bad or good without examining who might benefit or be harmed, to what degree, and with what probability. Way back in 2017, the AIGA Professional Design Organization's educators community released a white paper with their analysis regarding future trends that should guide what should be taught to design students looking forward to 2025, which of course is almost here. The first of 7 trends and competencies they discussed was complexity. They write about problems being situated within larger systems characterized by interdependent relationships among elements or activities. My students and I review this list in a couple of classes to note where we're aligning with their recommendations for things that the paper suggests college students should be learning. Of their list of suggestions, students probably learn the most about visually mapping relationships and considering impacts, numbers 2 and 5. Individual students vary widely in their focus on multiple scales or the nature of values, 1 and 6. Leveraging opportunities and enhancing overall effectiveness are probably the ones we engage with the least, given our short timelines and early stage design work. After exposure to emergent problem discovery, students express increased comfort with unexpected complexity. The acceleration of change calls into question the utility of merely teaching individual technologies and their known effects. The extremely rich discussion around artificial intelligence is a great current example of this. Everything is changing so fast, including impacts and implications, that instead of being taught today's technology, learning how to learn about tomorrow's technology is probably one of the most valuable skills students can acquire. But students first require the knowledge and confidence they'll need to face the increasingly inevitable unexpected. The intersection of design, complex systems, and rapid technological change is critical for both students and instructors to engage with, as we're continuously required to relearn how to learn. I personally value meeting students where they are and helping them achieve their diverse learning goals despite the added teaching complexity. Thank you, and please feel free to contact me with questions or feedback.